Mars is no longer the planet it was. In September, 2 weeks ago, something passed within 20-9 million kilometers of the red planet with surgical precision, and it left something behind. Not a crater, not a scar you could see from orbit, something far more subtle and potentially far more significant. For months, Senai Atlas, an interstellar visitor from beyond our solar system, has been spraying 140 Zen-4 metric tons of water into space every single hour. Along with that water, refined nickel at 4.6 grams per second, hydrogen cyanide ramping exponentially to over 60 grams per second, and ionized plasma streaming behind it like a chemical banner. On October 3rd, 2020 Gen 5, Mars flew directly through that banner. Multiple orbiters watched it happen. The chemistry is verifiable. The numbers are published. What nobody's talking about yet is what happens next. Because in 14 months, SpaceX is sending autonomous robots to dig into Martian soil, and they're going to find exactly what this comet left behind. Before you dismiss this as science fiction, I want you to consider something. Everything I'm about to tell you is built on published scientific data, verified observations, and mission timelines that are already locked in. This isn't speculation about distant possibilities. This is documentation of what is happening right now on a schedule you can mark on your calendar. If you're watching this, you're early to a story that will define the next chapter of Mars exploration. Hit that like button if you're ready to connect some dots most people haven't noticed yet, and drop a comment telling me where you're listening from, because this discovery affects everyone's future in space whether we're ready for it or not. Chapter 1. The Observations and the Flyby. Let's begin with what we know for certain. October 3rd, 2020 Gen 5. While most of the world was focused on terrestrial concerns, 3 spacecraft in Martian orbit recorded something unprecedented. ESA's Mars Express, NASA's Mars Reconnaissance Orbiter, and India's Mars Orbiter mission all tracked the passage of Senai Atlas as it swept past the red planet at a distance of 20-8.94 million kilometers. To put that in perspective, that is about 3 Zen-quarters of the distance between Earth and Mars at their closest approach. For an object that originated outside our solar system, traveling at 60 Zen-5 kilometers per second relative to the Sun, coming within that range of Mars represents a geometric precision that is almost uncomfortable to consider. The Swift Observatory had been tracking Senai Atlas since it crossed Earth's orbit in August. The comet was bright, far brighter than models predicted it should be at that distance from the Sun. That brightness came from outgassing, the process where frozen volatiles sublimate off the comet's nucleus and form the characteristic coma and tail. But this wasn't ordinary outgassing. In late August, Swift's ultraviolet spectrograph measured water production at 140 Zen-4 metric tons per hour. Think about that number for a moment. That is a fire hose running at full blast continuously for weeks, and it wasn't slowing down. By mid-September, as Senai Atlas approached its October 3rd perihelion, the point in its orbit where it would be closest to the Sun, that water production had remained constant. Chapter 2. Anomalous emissions. Cyanide and nickel, but something else was accelerating. The Keck Observatory in Hawaii had been conducting spectroscopic observations throughout September, and they detected something that made planetary scientists take notice. Hydrogen cyanide (HCN) emissions were increasing exponentially. In late August, measurements showed HCN production at approximately 17.6 grams per second.